All right, so as we are going to apply circumference to some more complicated problems, we need some background information. And as we did, we know circumference formulas, we have some conversion, and finally, we're going to need to know speed at some point. All right. So looking at number 1, Alfonso's Pizzeria bakes olive pieces in the outer crust of its 20-inch diameter. So there's key, diameter pizza. There's at least 1 olive per inch of crust. So how many olive pieces will you get in 1 slice of pizza if we are cut in 8s? So, quick question. If the circumference on this, and you don't need to draw this, if this was 10 inches all the way around, how many olive pieces would you have? So here, if it were 10 inches, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 olives in that one. So effectively, we're doing this. We're finding the circumference, and then that'll tell us how many olive pieces we have, and then from there, we can divide by 8. Okay, so let's find the circumference. C equals, I'm going to use pi d because of the diameter they gave to me there, 20. When I substitute in, I get pi times 20. And now I can multiply out with my calculator. And let me actually change this to an approximate value. Approximately here, and 62.8 inches. So if we were to say how many olives, there would be about, and we could round it up, 63 olives total. Now, what do we divide by? We divide by 8 because that's how many slices there are. And so now we get our answer, and we could even round up the 64 to 64, and just at this point not even use a calculator, or if you did a calculator, then you can just round up. But it's about 8 olives per slice. And it's okay to be approximation here. Now looking at number 2. To use the machine at the right, you turn the crank, and which turns the pulley wheel, and which winds the rope and lifts the box. Through how many rotations must you crank to lift the box 10 feet? Good. So let's take here. Remember that the rope gets pulled around like this, which is 1 circumference. And as it gets pulled up, it'll get pulled up that much. And 2 circumferences would pull it even more. And 3 cranks would take it even further. So ultimately, we are going to find the circumference and then divide that into the length of my rope here. Good. So we're using C equals 2 pi r because they gave us the radius, and we're going to find the circumference. So we substitute in the 7.5 times 7.5 to get exactly 15 pi inches, and now we can multiply out. So approximately 47.1 inches. Now, if we convert the 10 feet to inches, that's 120 inches. A double the apostrophe, there are the quotes, mean inches. So now we take the 120, and we can divide it by the 47.1 to get an approximate number of cranks. And so our final answer here will be 2.54. And so what's the answer as a sentence? So now I'm going to crank it about 2.5 times. A satellite in geostationary orbit stays over the same spot on Earth. The satellite complete 1 orbit the same time the Earth rotates. And notice, as we said earlier, it turns out that it's not exactly 24 hours. very close. If the satellite's orbit has a radius of this many meters, so quite a bit, it's quite a bit out there. If we subtract 3 from here, we'll get, so 4, 2, 3. You don't need to write this, just putting it out. 1, 2, 3, 4. It's this many kilometers out from the Earth. Or not necessarily, is it from the Earth? But we have to refresh what speed is. Velocity. Velocity is the distance traveled divided by time. And note that we are asked to find per second. So we have to convert hours to minutes to seconds. And distance we're going to keep at, does it say meters? So we're going to keep it at meters. So we don't have to convert it at all. So my answer is going to be meters per second. So I do have to do one conversion for time. So now we have the velocity or speed formula, which is distance over time. And we want it to be in meters per second. So we already have the meters. However, we want to know what the distance around is. So that's a circumference question. So I'm going to say circumference is 2 pi r, and I'm using that formula because they gave us the radius. So now I'm going to substitute in the appropriate amount, which is a very large number, times 10 to the 7th power. Now, what's nice about scientific notation is that we could just multiply the 2 pi by the 4.23 and effectively ignore this for now. At the end, we'll clean it up and bring it back down, but we're going to ignore that. So when you multiply with a calculator, you get approximately 26.578 times 10 to the 7th. So this tells you how many meters around the Earth that it goes, which is quite large. Now, according to this, we have d divided by t. So I take this distance, which is the circumference, and I'm going to divide by time. Well, in nearly 24 hours, it goes around once. So I'm going to divide by 24, or roughly, but I also have to convert it to seconds. So let's see what it looks like. We're going to say my velocity is approximately, and let me change that to an approximate sign right there, 26.578 times 10 to the 7th power, and I'm going to divide by my time, which is 23.93 hours. Now, while we're here, we can do the other conversions as well. We know that 1 hour is equal to 60 minutes. I'm going to change color here so it's a little bit easier to see. Now, why did I do that? Well, notice here that I have an hour in the denominator, an hour in the numerator. So that means the hours can actually cancel out too. And so let me repeat that with one more. I'm going to say it's now times, what about minutes? Well, 1 minute is equivalent to 60 seconds. So notice what we're going to be doing. We're going to be taking the 26, we're going to divide it by the 24-ish, then we're going to divide by 60 because that's in the denominator, and we're going to divide by 60 again. So with your calculator, do the 26.578 divided by 23.93, divide by 60, divide by 60. And your approximate value give you this. 0.000308 times 10 to the 7th. Now, scientific notation demands that we can take the 7 here and move our exponent over 1, 2, 3, 4, 5, 6, 7. And when we do that, it actually gets rid of all those zeros. So I end up with 3085. And notice we're at meters, because that's the original here, meters. And notice the hours dropped out, minutes dropped out, and I'm left with seconds. Meters per second. So there's my answer, 3,085 meters per second. Then, of course, you can ask Siri or Google, what is 3,800... Let me try that again. What is 3,085 meters per second in miles per hour?
I believe someone just asked me this the other day. Give me a sec. 3,085 meters per second converts to about 6,901 miles per hour.
6,901 mile per hour. Now, that wasn't part of the question, but I just wanted to put this more into perspective, which is more than double our velocity on the planet.